All right, finding conditional probability, last part of 5.2, and which we've already looked at conditional probability just without that name. Conditional probability was probability that looked like this. Like, what's the probability of B happening given that A has already happened? That's called conditional probability. The probability that something happens based on the condition that something else already happened. So a lot of these problems that you get are given to you in a table. So for example, a quality control inspector checks for defective parts. Sounds like a really boring job. The table shows the results of the inspector's work. So the inspector found defective and non-defective parts, and then it shows if they passed or if they failed. So find the probability that a defective part passes. So it's not asking you to find a probability that a part passes. It's wanting you to find a probability that a defective part passes. So when you would write that, you would say the probability that something passes that is already defective. So what's the probability that something passes given that it is defective? And if I look at this list, the total number of defective is what's going to go on the bottom, right? So out of all of the defectives, let's see, there's 3 that pass, 36 that fail. So that means there's 39 defective parts. How many of those passed goes on top? 3 out of the 39 passed. So that would equal 1 out of what, 13? So 1 out of 13 defective parts don't get caught. They actually pass. Then it says, what's the probability that a non-defective part fails? So what's the probability that a part fails if it's non-defective? So if I look at the non-defective list right here, if I add those together, that's 461 parts that are not defective. 11 of those fail. Even though they're not defective, they still fail. So it would be 11 out of 461 fail if they are already defective. All right, so that's called conditional probability. What's the probability that something happens given the condition that something else already happened? Okay, now this showed up in a formula. Earlier, you learned about dependent events, and this conditional probability showed up right here in the dependent event formula. And we're going to use this formula to find conditional probability, because sometimes it gives you a table, which it's really easy to do with a table. Sometimes it doesn't. So this one says, at a school, 60% of students buy lunch. Okay, so the probability of lunch is 60%. Only 10% of students buy lunch and dessert. So the probability of lunch and dessert is 10%. What's the probability that a student who buys lunch also buys dessert? So it wants to know, what's the probability that if someone has already bought lunch, that they also are going to buy dessert? Well, I can do this because I have a formula. I just need to plug the different pieces in. The probability of both of them happening goes right there. The probability of just buying lunch goes right there, which leaves me to find the unknown part. So probability of both of these things happening is 10%. So I'm going to write that as 0.10. And that's going to equal the probability of just lunch, which is 0.60, multiplied by what I'm looking for, the probability of buying dessert if they've already bought lunch. Now I can just do my railroad tracks and divide by 0.60. and I get 1 out of 6 is the probability that someone who bought lunch also buys dessert. You could rewrite this formula if it's easier. This formula right here, we can just rewrite it to be the probability of B given A equals the probability of A and B on top divided by the probability of just A. So let's try another one using that formula. Actually, maybe we'll take it with us. Let's take this formula. Hello. I'm going to copy that and we're going to move it down here. All right, so we're going to use this same idea. In example 6, find the probability that, oh, never mind, we're not because we have a table. Find the probability that a non-defective part passes. So the probability, where's my pen? Probability that something passes that is non-defective, and the probability that a defective part fails. So something fails if it's defective. All right, so going back up to my table, what are the chances that something passes if it's already non-defective? So that's this row right here. It's already non-defective, so there's 461 total. How many of them pass? Well, 450 out of 461. So 450 pass out of the 461 that are not defective. What's the probability that something fails if it is defective? Well, if it's defective, that's this row right here. And total, there's 39 on that row. How many of them fail is right there, 36 out of 39. So what, 12 out of 13? So 36 out of 39 are going to fail if it is defective. And I don't know if that's good or bad. I don't know that much about checking, what do they call it, quality control. Maybe that's a high percentage. Maybe that's not a very high percentage. I don't know. At a coffee shop, 80% of customers order coffee. So the probability of ordering coffee is 80%. Only 15% of customers order coffee and a bagel. So the probability of coffee and a bagel is 15%. What is the probability that a customer who orders coffee orders a bagel? So what's the probability that someone orders a bagel if they've already ordered coffee? So I can use my cool little formula to set this one up. The probability that someone buys a bagel if they've already bought coffee equals the probability that they did both, that's 15%, divided by the probability that they bought coffee, which is 80%, which you could rewrite as 0.15 over 0.8, which is what, 15 over 80, which we could 5 goes into both of those, so 3 over 16. So 3 out of 16 probability that if someone buys coffee, they're also going to buy a bagel. All right, 5.2, last section of homework. Go ahead and do numbers 21 through 24. 21 and 22 are going to give you a table. 23 and 24 are not going to give you a table. You're going to have to use the formula to find 23 and 24.